Good morning, all. So today we're going to start something new. And for this topic, graphing and solving quadratics, it's extremely important that you go onto the Google Classroom and you click on classwork and scroll down to materials for the course. We are definitely going to be using graphing calculators during this topic, and I have provided several applications that you can download to your phone or to your PC in order to utilize a graphing calculator. It's also important that you go to that materials for the course and download the packet. It's Unit 8, Graphing Quadratics. You can download the packet to your phone or to your computer, and if you have access to a printer, you can print the packet as well. If you cannot print the packet, I would definitely take down the notes by hand. And if you have access to graphing paper, I would definitely use that as well. I'm going to try and make this as easy on you as possible, but it will make it much easier if you have access to a graphing calculator and some graph paper and the packet. Okay, so without any further ado, let's jump into the last unit of the school year. So, graphing and solving quadratics. Now, what is a quadratic? A quadratic is a line just like y equals mx plus b, but instead of y equals mx plus b, it looks something like y equals ax squared plus bx plus c. Okay? Now, normally, we're used to working with y equals mx plus b, where m is the slope and b is the y-intercept. But we're no longer talking about this anymore. Now we're talking about quadratic formula, okay? Now, jumping right in to graphing a quadratic. Let's look over here. It says graph y equals x squared. You can see that my a in this situation would be an invisible 1. My b and my c would both be 0 because I don't have a plus or minus bx or a plus or minus c. Essentially, this is a very simple example of a quadratic formula. So, y equals x squared. That means that for every x that I have, I'm going to square it to get the y. So essentially, I'm just going to say 3 squared is 9. 2 squared is 4. 1 squared is 1. 0 squared is 0. Negative 1 squared is 1, because remember, a negative times a negative is a positive. Negative 2 squared is 4, and negative 3 squared is 9. Now, before we go any further, I'd like to point out that there is a pattern here. I go 9, 4, 1, 0, 1, 4, 9. Do you see the pattern? And it would repeat like this to infinity as long as I'm writing numbers. Like if I did a 4 up here, it would be 4 squared is 16. And if I did negative 4 down here and square it, I'd also get 16. So the pattern would repeat with as many numbers as I write. But for the ease of this example, I'm just doing these 7 numbers. Okay, so let's graph these numbers onto this coordinate plane. So if my x is 3 and my y is 9, I'm going to go over 3 and up 9 and put a dot right there. That takes care of the first point. Then 2, 4. So I go over 2 and up 4. There's the second point. Now 1, 1. I'm going to go over to the 1 and up 1. There's the third point. Then I have 0, 0. 0, 0 is just the origin. So that takes care of that point. Then I have negative 1, 1. So I'm going to go over to the negative 1 and then up 1. Next, I'm doing negative 2, 4. I'm going to go over to the negative 2 and up 4. And lastly, negative 3, 9. I'm going to go over to the negative 3 and up 9. Now, those are my points. And all I need to do now is connect the dots as best I can. So I'm going to draw a line that connects all of the points as best I can. Now, please bear with me. I'm writing on my computer screen. It's not as easy as it looks. But here is the curve of y equals x squared. Notice that it is not a straight line. It is a U shape. Let's scroll down for a minute. I have a question here. It says, what can you tell me about this graph? Well, let's take a look again. Remember, I said it's not a straight line. So let's write that down. It's not a straight line. We're very much used to graphing straight lines. Now we're going to start graphing these lines. Now, this line in particular has a special name. It's called a parabola. We will not be using that name very much, but I just wanted you to be familiar with that vocab word. This is called a parabola. What else can we say about the line? Well, there is a repeating pattern of points. And what you will notice as we go through this unit is that that will always hold true. There will always be a repeating pattern of points. What makes it different from other graphs that we have done in the past? Well, first of all, it's curved. Also, it is a quadratic function, not a linear one. So like I said before, in the past, we have been used to graphing y equals mx plus b. And those lines typically look like a straight line going up or a straight line going down. Now we'll be working with these curved lines. Okay, so that is a good example of a quadratic function and what it looks like. I'll hover here for a moment so that you can pause the video and write down the notes if you're working out of the packet. Okay, let's move on to page 2. Okay, so here on page 2, you can see that there is another example of a parabola. This curved line, remember, is called a parabola. Now, this one looks very similar to the one that we completed on page 1, but it's a little different. It's a little lower on the graph. So I want to use this picture to introduce some vocabulary to you. First, I want to talk about what roots and zeros are. The roots and the zeros are where the quadratic line cross the x-axis. And really what this means is where y equals 0. Now to clarify this, I'm going to go back up to the picture and I'm going to show you exactly what I mean. So the roots of this equation would be right here and right here. It's where the line crosses the x-axis, and here is the x-axis. Now, as you can see, there are two roots. There's one right here and one right here. Now, we will go through some problems, and I will show you how to calculate what the roots of the equation are. I'm going to also show you how to find the roots on a graphing calculator. So like I said before, it's very important that you go to the Google Classroom, go to classwork, scroll down to materials for the course, and look into getting yourself a graphing calculator either on your phone or on your PC. Okay, moving on. What is the vertex or the turning point? The vertex or the turning point is where the line reaches its max or min. Its maximum or minimum. So looking back at the picture, the turning point would be this point right here. It's where the line reaches its lowest point and then starts back up. As you can see, I'll choose a different color. The line starts moving down this way. It hits this minimum and it starts to go back up. So the turning point or the vertex is this point. And then these are the roots. Okay. The axis of symmetry. Just to review, the word symmetry should be a word that you're familiar with. But just as a quick review, a line of symmetry is a line that cuts a shape or an object in half such that you can fold the object in half and get two equal parts. In this case, we're talking about a line that cuts the parabola in half so that you could fold it over on itself and it would give you two equal parts. So it would kind of look something like this. Okay? In this case, the axis of symmetry would be the y-axis, because if I draw a line straight down the y-axis, it cuts the parabola in half. There's an equal part here and an equal part here. So, how do I figure out what the equation for that line is? Well, there's a formula. The formula is negative b over 2a, such that we're talking about ax squared plus bx plus c. Now, I'm just introducing this concept to you today. We will go over this in more depth as we move forward through the unit, but I just wanted to make you aware of this function. Please make a note of that in your notes, okay? Now, the last vocab words are maximum and minimum. And this has to do with the vertex and the turning point. Your max and your min and the vertex and the turning point are almost interchangeable. They're almost the same thing. In this case, what we're talking about is this point right here. That would be the minimum of the parabola. It's its lowest point on the graph. So for graphs that look like this, the turning point or the minimum is right there. It's the lowest point. And as you can see, typically, the axis of symmetry will go through the minimum point. But then for lines that look like this, the turning point would be up here. That would be a max. But again, the line of symmetry would go through that turning point, would go through that maximum, okay? Okay, so those are the vocab words that I wanted to introduce to you today. Just as a reminder, there will be a bell ringer and a homework assignment associated with this lesson. I know this is lots of new stuff, and I don't want you to be too worried. We're going to go over each thing in more detail as we move forward, okay? So keep up the good work, guys, and as always, please stay safe.